And full screen. So, before I do this, this is what I want to talk about. I completely forgot about this. All right, so I gotta get my Windows here going. All right, Blackboard, sign in, 04. All right, here we go. Guided notes. All the way down, factoring polynomial flowchart. So let's open up this bad boy. All right, so here we go. This, if I were you, I would rewrite it exactly how it looks, or I would print it up and I'd have it to your left every single time you do a problem now. Here is the way that we start every single problem, okay? So the idea or the question, I don't know where to begin, this is where you begin right here. So the first thing, you always want to ask yourself, can you factor out a GCF? Okay? Next, you're going to ask yourself, what is a polynomial type? And you only have 3 answers so far. You only got 3. A binomial, which means 2 terms. A trinomial, which means 3 terms. And then polynomials with 4 terms. Okay? Pre-calculus, that's where you get 5 terms, 6 terms, and so forth. Okay? So, factor out a GCF. Ask yourself, what is the polynomial type? So today, we're going to be looking at binomials that are perfect squares. Okay? And we're going to look at binomials that are perfect cubes. But what's nice about this flowchart is if you can just identify what type of problem you have, notice it has the formulas here for you already. That's great. I mean, we've already looked at polynomial types of trinomials where a equals 1. If a equals 1, you just literally go right into your, write out your 2 binomials, write down the x's, copy down the first sign, find the second sign, and then find the 2 factors. That's what F1 and F2 mean right here. That's what F1 and F2 means. Factor 1, factor 2, okay? So multiply factor 1 and factor 2 to get C. And add to get B. That's the easy one. Now, if your trinomial does not have a leading coefficient of 1, in other words, it's different, use the AC method. So it tells you exactly what to do. Okay? You still got to know how to factor this stuff. But at least this helps you to organize your thoughts. Okay? So please, it's been up here. This has been posted since like last week. I think I did it like Thursday or Friday. I can't remember. All right? But I figured, we'll go over it in class. All right? So make sure you have this with you. This will help. Okay? So like I said, today, we are going to finish up our factoring techniques by looking at this entire top portion right here. All right? So it's actually very simple because there are formulas. So let's look at them. Oops. So, in this section, we're going to be looking at factoring binomials. 2 terms, specifically factoring the difference of squares and the sum and difference of cubes. Now, the first one we're going to look at, all right, is called the factoring the difference of squares. So you got to think about what that means. Difference, subtraction, squares means you got to have some squares. So let me show you what that is. So in chapter 12, we looked at an example like this, where we said, okay, let's multiply x plus 5 and x minus 5. And if I do this off to the right here, x plus 5 times x minus 5, okay? We found that when we multiplied, and we combined our like terms, we found that this middle term right here actually always canceled itself out. The middle term always canceled itself out. Plus 5, negative 5. And then we said, well, that's actually kind of special. We called that the sum and difference of binomials. That's what we called it. Well, now we're going the opposite direction. In other words, what you got to be able to recognize is this. If you have, and now I'm actually going to scroll up just a little bit. I'm going to zoom in just a little bit because I'm looking at this box right here. So this technique is called factoring the difference of squares. And what you got to be able to recognize is, number one, you have two terms. That's the first thing. The second thing, you got a minus sign. And then the third thing, perfect squares. Okay, now a perfect square is exactly what it sounds like. If you have a square, okay, you know that what makes a square so special is that, and I'll use an actual number, is that the sides are all the same exact number. So I'm going to give us a list of perfect squares that we should know. 1 squared equals 1. 2 squared equals 2. 3 squared equals 3. 4 squared equals... Oh, what am I doing here? 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared equals 81. 10 squared equals 100. And I'll give you a couple more. 11 squared is 121. 12 squared is 144. 13 squared is 169. Those are the biggies. Those are the biggies. Those are the ones, and I know, at least I hope you know this. You really never hear me say, I want you to memorize this. I always say, know the technique, understand the application. This I want you to memorize. We should know what those squares are, okay? Now, what makes this so easy is once you're able to recognize, just like in example 1, we have two perfect squares. You have x squared, and you got a minus sign in between them. So if you have perfect squares and a minus, that can be factored. And it'll always factor down. And I'm going to highlight this. It'll factor down into the multiplication of two binomials where the numbers and the letters are the same. It's just they differ in signs in the middle. So the hardest part here, I think, is labeling things. So I'm going to label the first couple, but then after that, I'm not going to label. So in this situation, in my formula, if I have a squared minus b squared, that factors down into a plus b times a minus b. So in my specific example, the letter a, I'm going to let equal x, and the letter b is going to be 9, because 9 squared equals 81. So this will factor down into x plus 9 and x minus 9. And that's it. Notice you don't have to worry about finding numbers, writing down signs, taking a times c, rewriting the middle term. I mean, there's none of that. It is just a formula. All you got to do is follow it. All right? For the second example, x squared minus 64. This is a difference of two squares. So this will factor down into x plus 8 and x minus 8. What do you think? Pretty easy so far? It should be, because the work is done. Now, number 3 may look a little difficult, but it's not. You got to remember the name of the technique that we are learning. Difference of two squares. So, if you look at number 3, I got that difference. I got that minus sign. So when I look at the very first term, that 9x squared, you got to think, is 9 a perfect square? Yes, it's right here. So what squared equals 9? Well, that's going to be 3. X to the second power, no matter what it is, it's always going to be a perfect square because it's squared already. So what you got to be able to do is just think, what number squared equals 9? And then we're going to write it in parentheses. So 3x raised to the second power. B is just going to be the number 1 because 1 squared is 1. So when I factor this, I get 3x plus 1. Let me write this a little cleaner. 3x plus 1, and 3x minus 1. And that's it. You can always check yourself. Now, by checking yourself, hopefully you know, or at least you can recognize that this is the sum and difference of binomials. So the only thing that you have to multiply are the first terms and the last terms. And that's how you check yourself. All right? So I'm going to let you do number 4. I want somebody to tell me what number 4 equals. If you can get number 4, this is easy stuff. All right, what's number 4? Who got an answer?
6a plus 7b times 6a minus 7b.
Perfect. Excellent job. Because when you think about it, 36 is 6 squared, and 49 is 7 squared. So it's going to be 6a plus 7b and 6a minus 7b. Good. What about number 5? It has a fraction. But all we're concerned with is, do we have difference of 2 squares? Well, we got a difference. That's good. You got p squared up front. That's good. But now you got to worry about this fraction. But look at it. The numerator is 25 and the denominator is 36. So I already know this is going to be p plus and p minus. The question becomes, what's the fraction? Well, what number squared is 25? And what number squared is 36?
6.
So it's going to be 5 over 6 minus 5 over 6. How are we looking? Pretty good? Is it making sense? All right. Good, 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 good. Now, this is the first time that we've ever seen something like this. Oh, sorry. Am I moving too fast? Give you a second to write that down. I don't want to move too fast. All right, now I'm going to scroll up. So number 6, we got to be really careful. First, it's z to the 4th minus 81. Okay? This doesn't have the difference of squares look quite yet. All right? And what I mean by that is we are looking for z to the 2nd power, correct? I mean, that's what we really want. But if you think about it, when you have a power raised to another power, you multiply them, correct? So I definitely have difference of squares here. It's kind of hidden, all right? Now, first thing I'm going to do is just go ahead and factor this using my difference of squares technique. I know this is going to be z squared plus z squared minus, and the 81 is going to be 9. But here's the thing that we always want to make sure. I'm going to put a star. You always want to check after you factor if there's any more additional factoring that you have to do. Okay? And I'm going to tell you this right now. Okay? I am going to put a question like this on your test. You will see a question like this on your final. 100%. Because when you factor z to the fourth minus 81, initially you get z squared plus 9 and z squared minus 9. And this is the difference of squares again. So this will actually factor down into z squared plus 9, and then times the quantity z plus 3 and z minus 3. So you may, just because you factor once, doesn't mean that you are necessarily done. Okay? Does that make sense, everybody? Now, some of you may be asking yourself, okay, well, if that's the case, how come you didn't do the z squared plus 9? Am I right, Jada? All right, well, look at question 7. Very similar. And I'm also going to do this for us. I'm going to pull this up. Now, we know we are dealing with binomials, perfect squares. But real quick, what is the sign? What is the sign right here in between the z squared and the 9? What is that? A positive, correct? So look at your flow chart now. You got perfect squares, sum, and what's it say? It does not factor. Okay? So this difference of squares things, or this difference of square technique, all the information we need is in the name. It has to be a minus sign. If it's a plus, you cannot factor. So m squared plus 49, you cannot factor that. That is not the difference of squares. Okay? Are there any questions there? All right. So let's look at number 8. Now, number 8, we start adding on to this, okay? So remember your flow chart. Step 1, factor out a GCF if it exists. I look here, I look here. I cannot factor out a coefficient, but I can definitely factor out an x. Okay? So now that I factor out an x, I still got to ask myself, can I still factor? Well, if you look inside the parentheses, you got a minus sign and perfect squares. So this can be factored down into 2x plus 7 and 2x minus 7. Okay? So we're always going to be asking ourselves this now. Can you factor out a GCF? What's the polynomial type? And then it'll tell you what to do. Number 9. See, once you know, this goes real fast. All right, so number 9. I can factor out a GCF. It's a 5. So I'm left over with 5 times the quantity, 16y to the 4th minus 1. Now, be careful. This 16y to the 4th minus 1 is exactly like that previous problem we did where we had that to the 4th thing. So make sure you check after you're done. So first, this is going to be 5 times 4y plus 1, or 4y squared plus 1, and 4y squared minus 1. Now, this last term, that last binomial, is another difference of squares. So you have to factor again. So that's going to give me 5 times the quantity, 4y squared plus 1, times 2y plus 1, and 2y minus 1. All right? I'm telling you, it's gonna appear on a test. So if you stop early, you're only gonna get half credit. You got to make sure you completely factor. Okay? All right. Are there any questions? Am I moving too fast? Or are we all right? Who wants to see a picture of Artie? There you go. He's sleeping right now. Look at this. Sleeping on his back. He's a happy dog. He has way too many toys, by the way. All right. So here we go. Next. Number 10. We need to be careful. Because remember, and I know I went over this. We don't like negatives. On our first term. Okay? So we always factor out a negative. Because right now, this looks like it cannot be factored. Looks like it. But what we're going to do is factor out a negative 1. And by doing that, remember, factoring out a negative 1 switches signs. That's all it does. It switches signs. So now that I factor out the negative 1, I totally have difference of squares inside the parentheses. So this is going to be negative 1 times 3x plus 10 and 3x minus 10. Personally, I think those are the most tricky. I do. Because initially it looks like there's nothing you can do, but you got to factor out a negative. All right. So are there any questions with factoring out difference of squares? All right, like I said, if you know like 2 or 3 of them, you know them all. It's just a matter of recognizing it. So the second thing we're going to learn out of this section is the sum or difference of cubes. Okay? Now we have formulas here, which is really nice for us. And our technique, our approach is the exact same as difference of squares. We're gonna label what A is, we're gonna label what B is, and then you just make these substitutions into your formula. Okay? So sometimes it can get a little difficult, and the only time it gets difficult is because you're either not writing clearly or you're forgetting to put things in parentheses. Because what you got to remember here, and I'll do the A cubed plus B cubed one. You got to remember that the thing being squared, whether it's the A or the B, it's that entire term that is being squared. All right? So personally, what I like to do is just write parentheses first, and then I'll clean it up. Then what I do is I clean it up, I square everything. All right? All right, so let me do the first one. Let me show you what I mean here, okay? Oh, how about we do this before? I'm going to write out some perfect cubes for you. These, you got to know. So 1 to the third is 1. 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. And 6 to the third is 216. Sometimes we say like 1 cubed, 2 cubed, 3 cubed, and so forth, because if we actually draw the shape, it's an actual cube that you're creating, where the length, the width, and the height are all the same exact number. Okay? So that's why sometimes we say cubed. It's because it represents a cube, which is its shape. So here we go. X to the third plus 64. So what I'm going to do is label. So in this situation here, A is X and B is 4. I'm going to actually write the formula directly above, just so we can see how this works. All right. Now for us, x cubed plus 64 is going to equal x plus 4. And then we have x squared minus x times 4 plus 4 squared. So notice I just kind of put in where they belong. Wherever I see an A, I write the letter X. Wherever I see a B, I write the number 4. Now I'll clean it up. I'll make it look nice. Quantity of x plus 4 times x squared minus 4x plus 16. Okay? And that is factored. What's also nice is that second trinomial, that second factor, x squared minus 4x plus 16, you cannot factor that. If we could, we would have showed you it in the formula. So once you recognize, oh, this is the sum of cubes, just use the formula and simplify it. That's it. Any questions? All right, let's do the next one. Can somebody tell me what A is going to equal? 3, very good. Oh, it's a little bit more than that. 3 is the start of it.
3y.
Good, 3y. B is going to be 1. Okay, so make sure that we see that. Okay? Remember, 3 to the third is 27. And then you got that y to the third. So let's go ahead. Let's use our formula. Wherever we see the letter A, we're going to write 3y. Wherever we see the letter B, we're going to write 1. So I get 3y plus 1. And then 3y, quantity squared, minus 3y times 1 plus 1 squared. Now I'll clean it up. In the first set of parentheses, the binomial will be 3y plus 1. In the second set of parentheses, that trinomial, we got to simplify. 3y to the quantity of 3y to the second power is 9y squared. Minus 3y times 1 is 3y. And then 1 squared is 1. Okay? All right, are there any questions? Is it making sense? Pretty straightforward. All right, let's do the last one. I think it's the last one. Yeah, it's the last one. 32x to the third minus 500y to the third. All right? Now, remember, we always look for a GCF first. Is there a GCF here? For those of you shaking your head no, you better be careful. You better be careful.
4.
4. We have a GCF of 4. Okay? We get a GCF of 4. Now the question becomes, inside the parentheses, can this still be factored? Well, you got 8x cubed minus 125y cubed. The 8 and the 125 are definitely perfect cubes. Then you have x cubed and y cubed. Well, they're perfect cubes as well. So, label things, take your time, make the appropriate substitutions. I'm going to write the formula out for us. There's our formula. A cubed minus b cubed equals the quantity a minus b times a squared plus ab plus b squared. Now I need to figure out, okay, in my formula, what is going to be letter A and what is going to be letter B. So for letter A, what number cubed equals 8?
2x.
Good. So letter A is going to be 2x. Letter B in my formula. What number cubed equals 125?
5.
Good. So the second one is going to be 5y. Now, write big, write neat, so you can see everything. So this is going to equal, we got a 4 out front. Now, we're going to write 2x minus 5y. That's a minus b. Now, remember, you make the substitutions, put it in parentheses first. So I'm going to get 2x squared, quantity 2x squared, plus 2x times 5y, plus the quantity 5y squared. Okay? This is by far the hardest part, is by just writing it neat. Now, we're going to clean it up. Nothing changes with the 4, and nothing changes with the 2x minus 5y. What is 2x? What is the quantity 2x to the second power? Well, 2 squared is 4, and x squared is x squared. Plus, 2 times 5 is 10, xy. And then lastly, the quantity 5y squared. Well, 5 squared is 25. And y squared is y squared. Now, I don't know about you. Although this problem looked a little difficult, it wasn't that bad. And also, I think my handwriting looks really, really good. Because I'm taking my time. I'm not rushing. I'm writing large. Okay?
I just have one question.
Go for it.
Where did the 4 come from?
I factored it out.
Factored it out from what, though?
32 x cubed minus 500 y cubed. So, they both have a 4 in common.
Okay. I was really confused on that.
Yeah. The 500 is what really throws people off because it's such a large number.
Okay.
Okay? What I would do, honestly, I need to rewrite the original problem, that's all. All right. Amanda, worst case scenario, here's what you do. You ready? 32 and 500, they're both even. Do you agree? So since they're both even, you can always factor out a 2. No matter what, you can always factor out a 2 if they're even. Now, 16 and 250, they're still even, correct? So I can factor out another 2. So out front here, 2 times 2 is 4. All right? Now, I'll try it one more time. 8 is even, but 125 is odd. 2 doesn't work anymore. You can try a 3, but what number times 3 gives you 8?
None.
See what I mean now? So remember, if the numbers are even, you can always just factor out a 2. And you can keep doing that until you can't anymore.
Okay, thank you. That helped a lot.
Okay, good, good. Are there any other questions? All right. Well, we've reached the moment in time in this section, excuse me, where we are actually done learning factoring techniques. There are no more techniques you got to worry about. If you take some higher level math, you may learn 1 or 2 additional techniques, but this is pretty much it, which is really, really nice for us. So what we're going to do is we're going to take everything that we learned from section 1 through section 5, all those techniques. And all those techniques, got to be honest with you, they're all summarized right here in this flow chart. This entire flow chart summarizes everything that we need. Okay? We're going to take this and we're going to learn how to solve equations. So if you think about it, you got this work shed, okay? So here's your work shed. And inside this shed, you got all these different things. You have prime numbers on this shelf. Over here you have, what else? Factoring. We'll put factoring there. Okay? Over here you have a box that's called solving linear equations. Okay, you got that box, right? You got another box on the floor that's adding, or better yet, I'll label it like this. Operations on signed numbers. Okay, you got that box over here on the floor over here. You got fractions. You got your fraction box. You can't forget about that. So you got all these different boxes with instructions on how to do problems. We're going to add another one, and it's called solving quadratic equations by factoring. So first, you got to have a quadratic equation. Second, the technique that we're going to learn is called factoring. And here's the thing. There's actually more techniques on how to solve a quadratic equation. There are more. We're going to focus on the first technique, which is called factoring. So a quadratic equation can be written in the form ax squared plus bx plus c equals 0. Remember, for an equation, you got to have an equal sign. And what we're going to do is we're going to set it equal to 0. Now, a, b, and c are going to be real numbers, so they can be any number you want. A is not allowed to equal 0, however. Because if a equals 0, then you're just left over with bx plus c, and that's a linear equation, which you would go back into your tool shed, and you get that box of instructions labeled solving linear equations. So, if you think about this, you got 2 different techniques now for solving equations. Linear and quadratic. Now, what makes this quadratic is this term right here that I'm underlining in black. That term, ax to the second power, makes it quadratic. Okay? So, anytime you see an equation and you see ax squared, or you just see x to the second power, you're going to want to do this technique, okay? You're going to want to do this technique. So some examples of quadratic equations I have are below. Something like x squared minus 9x minus 22 equals 0. That's a quadratic equation. 2x squared minus 24x equals 64. That's a quadratic equation because the highest degree, the highest exponent is the number 2. The third one, x times the quantity 2x minus 7 equals 4. I know it doesn't look quadratic because this x is raised to the first power and that x is raised to the first power. However, if you were to distribute, you get that 2x squared minus 7x equals 4. It's quadratic, okay? All right, are there any questions with that? All right, so we need to do a little bit of thinking here. We need to do just a little bit of thinking. So the idea behind this technique actually is summarized here. So, for example, let's say we had a quadratic equation. So we have this quadratic, and it can be factored. That is everything that we learned in sections, 2, 3, and 4? All right? So if this can be factored, then the same exact thing, if I set it equal to 0, is also factorable. In other words, let me give you a specific example here. X squared minus x minus 6 factors down into x minus 3 and x plus 2. Well, if I put an equals 0 on the right-hand side, that doesn't change anything. It's still factorable, okay? But here's what I know. In this second part, when I write the quadratic set equal to 0, when I write that in its factored form, and it equals 0, and this is huge right here. That means one of those two things has to be 0. I mean, if you think about it, I'm going to write above here. You don't have to write this. Just look, just watch and think about this. Somebody tell me, what's 3 times 0? What is it?
0.
Very good. What is 0 times 3?
0.
Did the order matter, Amanda? No. What mattered was, of the two factors that I'm multiplying, one of them was 0. And that forces the result, the product, the answer to be 0. It forces it. So if I have this x minus 3 times x plus 2 equals 0, and I know I need to solve for x, here's what I know. I know one of these two binomials has to be 0. Because the only way for me to multiply two things and to get an answer of 0 is if one of the original factors is equal to 0. Does that make sense, everyone? And that leads us into the zero factor theorem, which is that first gold box, okay? So the first gold box says that if you have a and b are real numbers, and if a times b equals 0, then a equals 0 or b equals 0. In other words, if you have two things that are being multiplied, and you know the answer is 0, one of those things has to be 0. There is no ifs, ands, or buts. 5 times 4 is 20, not 0. Does that make sense, everyone? This is an unbelievably powerful theorem. You will use this from now until you're basically done with math. All right? And directly below this box is our technique. If you can understand these 5 steps, you will get every single quadratic equation problem correct. So step 1, you're going to want to write the equation in standard form so that one side of the equation is equal to 0. What we're saying is make your equation look like this. make your equation look like that. ax squared plus bx plus c equals 0. Step 2, factor. I can sum that up in one word, factor. And you better make sure it's completely factored. Okay? So step 2, you need to know sections 1, 2, 3, 4, and 5 just to complete step 2. That's a lot. Step 3, set each factor containing the variable equal to 0. That is our 0 factor theorem. See, a theorem is like, it's like an additional tool. It's like something that you can use to help you solve a problem. Okay? Step 4, you're going to solve the resulting equations. And then step 5, you're going to check each solution in the original equation. All right, so real quick, while you're writing, I'm just going to say them again, and I'm just going to summarize it real fast. Step 1, set the equation equal to 0. Step 2, factor. Step 3, apply the 0 factor theorem to set each binomial equal to 0. It's a lot of words. You'll see it when you see it. Step 4, solve the resulting equations. And then step 5, all you're going to do is check yourself. So I'm going to scroll up, but I'm not going to cover up the directions, because we got some examples here. The first two, let me see the first two. The first 3 are very easy. Okay, the first 3 are really, really simple. Then the resulting ones obviously get more difficult. All right, so example 1. We have the quantity x plus 4 times the quantity x minus 5 equals 0. So step 1, write the equation in standard form. All right, standard form means set it equal to 0. Well, this is already set equal to 0. So step 1 is done. So I'll put a little check mark next to step 1. Step 2, factor. It's already factored. Notice I have the quantity of x plus 4 times the quantity of x minus 5. It's already factored. So put a little check mark there. Step 3, set each factor containing a variable equal to 0. Now this is the 0 factor theorem. So if you want to, watch what I do. I'm going to set each factor containing the variable equal to 0. So what I do is I separate them, and I just say, okay, x plus 4, you're equal to 0, and x minus 5, you're equal to 0. Now, step 3 is done. Step 4, I solve. So for the first one, to solve this, I subtract 4 from both sides. X equals negative 4. For the second equation, I add 5 to both sides. And that gives me x plus 5. So step 4 is done. Step 5, we just check in the original equation. Now let me show you what's happening here. And I can relate this back to everything that we've done so far. First thing I'm going to do, I'm going to let x equal negative 4. So watch what happens. I make my substitutions. I do the work inside the parentheses. And let me ask you, and then ask yourself a question. What is 0 times negative 9? Is it at 0? And didn't I say at the very start, when we were thinking about, okay, how can we devise a plan? If we have 2 binomials, and you know the answer is 0, that means one of those binomials has to be 0. So when x equals negative 4, the first binomial in this example is 0. Now we're going to let x equal 5. Well, if I make my substitutions, and I do the work inside the parentheses, notice I get 9 times 0. In other words, if x equals 5, then my second binomial is equal to 0. Okay? And hopefully by showing you this example, I can ask you this question. We know a quadratic equation is ax squared plus bx plus c. How many answers, how many solutions should we expect to find? Go ahead, Jada, say it.
2.
Why? You're correct. But can you tell me why? Just take a guess.
I'm so. We have 2 terms. That's why.
I'll buy that. I'll buy that. You have 2 factors, so you would expect 2, right? Is that what you're saying?
Yes.
Oh, perfect. And I agree with you. In fact, the reason why we can expect 2 terms, everyone, is right there. That exponent of 2 tells me that, you know what? You should be getting at least 2 terms. Isn't that amazing? Yes or no? I mean, I could be wrong. I could be wrong. I can't see you right now. I find it to be very, very interesting. I do. Am I weird? Amanda, did you shake your head yes?
No.
I could have swore you just shook your head yes.
No, it's cool though. It's cool.
You want to see something even cooler?
Yeah.
All right, give me a second here because I got to figure this one out. Wow, why is this all the way up there? Did I type it incorrectly? Maybe because I have it equal to 0. Maybe that's why it doesn't like it. Yeah, there we go. That's so much better. All right. Here's what's even cooler. I went to Desmos and just typed in x plus 4 times x minus 5. Now, here's what's amazing about this. First, look at the shape of that picture, that graph. We call that a parabola. Okay, we call it a parabola. Think about it. Your entire MAT090 all the way up to and including this point right now in time, all you've ever studied were straight lines. Now, you got this curve looking thing, okay? Second, the answers that we found, x equals -4 and x equals 5, look where they cross the x-axis. They cross the x-axis at -4 and when x equals -4 and x equals +5. Fascinating stuff. You don't understand how important those 2 points are right now. You will in the next section, which is solving quadratic application problems, because then those points actually mean something. Okay? Are there any questions so far? I get really, really nerdy around this stuff because it's interesting. It's like, whoa, okay. It's more than just adding fractions. It's so much more than that. But you can't do any of this without that foundation first. You gotta have a nice work shed before you can do any work. You gotta have the right tool. All right? Let's do the next one. Like I said, this one's pretty easy. Step 1, set it equal to 0. It's already done. Step 2, factor it. That's already done. Step 3, let's set each factor equal to 0. All right, now what we just did is we applied the 0 factor theorem. Now we're going to solve each one of these little problems. So for the first, I just add 12 to both sides. Okay? And then for the second, I will subtract 3. So that gives me 4x equals -3. And then I divide both sides by the leading coefficient. That's fancy words for the number in front of the variable. And we get a fraction for an answer, which is absolutely fine. You will get fractions for answers. It will happen. Okay? So in this case, x equals 12, x equals negative 3/4. Sometimes you'll write your answer like this. You will put them in squiggly braces, okay? On the homework, I think they already give you the squiggly braces. All you have to do is just type in the answers with a comma separating them. That's it. All right, so just make sure when you're going through your homework, you read how they want you to type in the answer. Just read it. All right? Don't worry, on a test, I always look at that stuff anyways. Good? All right. Let's look at number 3. Number 3, step 1, set it equal to 0. Step 2, factor. It's already factored. Now, if you can't see that, look here. I'm going to zoom in. There is your first factor. It's x. Here is your second. 7x minus 6. So you're going to set each one of these, which is step 3, equal to 0. Okay? The first one is done. I love that. Oh, I love it when that happens. X equals 0. There's no work you can do there. The second one requires a little bit of math. We add 6 to both sides. And then we divide both sides by 7. To give me x equals 6/7. All right? How are we looking so far? Pretty good? Pretty straightforward? All right. Number 4 is the first time we actually have to do some work. It's the first time we got to do something. So step 1, it's already solved for 0. It's already set equal to 0, so we're good. But step 2, now we got to factor. This is where this comes into play. Okay? So give me a second here. I'm going to do this. It's not going to look the best, but it's better than nothing. If we were in class, I would have brought up printed copies of this for you guys. That's what I would have done. And we would have just been looking at them. So we got to do this together. But first, Amanda has to give her cat a pet on the head before we can get started. Thank you. Oh, Artie's sneezing. Now, here we go. This is going to be fun. Step 1. Factor out a GCF. Well, our problem is x squared minus 8x minus 48. There is no GCF. That's fine. Step 2. Polynomial type. Well, our polynomial is x squared minus 8x minus 48. It has 3 terms. So that is a trinomial. Okay? How are we looking so far, everyone? All right. Now, I need to make a decision. The number in front of the coefficient, or the number in front of the leading term, is a 1. So that means a equals 1. So here is how you do the problem. And I even provided you with a little example to help to remind you. So we go directly into our 2 binomials. We write an x and an x. We always copy down the first sign. The second sign has to be a plus because when you multiply, you need it to be negative 48. So that second sign has to be a plus. All right? Now we write out the factors of 48. So off to the right, 1 times 48, 2 times 24, 3 times, 16? 4 times 12, 6 times 8. I need to combine these numbers because I know all of them, they all multiply to give me 48. That's great. But I need them to combine to give me negative 8. The only way that happens is positive 4 minus 12 equals negative 8. Does that make sense, everyone? So I go back over into my problem. Wherever I see the plus sign in my binomial, I put plus 4. And then x minus 8. Now step 2 is finally done. So I actually had to factor here. Step 3, I take each factor. I set it equal to 0. That's my 0 factor theorem. And now I solve each of these. So I get a final result of x equals 8 and x equals -4. Does that make sense, everyone? So
Lost you.
you lost me.
I think.
Where'd you lose me at?
I got x minus 12, x plus 4.
Oh, yeah, you know why? Because I'm stupid. Why did I write 8 and 4? Crystal, maybe you should be teaching the class.
No.
Does everybody see the mistake I made? Plus 4 and 12. Why did I write an 8? Maybe because 8 plus 4 is 12. I don't know. Man. Hey, you guys got to do me a favor. If I do that, you got to stop me instantly. That's an example of me being a snowflake at the beginning of class, and now I'm like this raging avalanche that's coming down the mountain. Like, I just keep going. So, sorry about that. So make sure you fix that. So our factored form is x minus 12 times x plus 4. We set each of those equal to 0, and then we solve respectively. So our two solutions are x equals 12 and x equals -4. Now, if you wanted to check yourself, you got to substitute those values in for x into the original equation, and you should get 0 for an answer. So let's go ahead. Let's just try it. All you got to do is watch. You don't have to write this down if you don't want to. I'm going to let x equal 12. So 12 squared is 144. 8 times 12, I think, is 96. 144 minus 96 is definitely 48. And 48 minus 48 is 0. Like, that should always work. All right? Provided your math is correct. Now, if I wanted to check the 4, get out of here, collapse, expand. There we go. So let x equal -4. Now, the only thing you got to be careful here, make sure you're writing those parentheses when you're substituting, because you don't want to miss a sign. -4 to the second power is 16. Negative times a negative is a positive. So that's going to be plus 32 minus 48. 16 plus 32 is 48, and 48 minus 48 is 0. So I know both of my answers are definitely correct. All right, any questions? Any questions? All right, let's do number 9 together, and then I'm going to have you do number 6. So number 9. Step 1, I got to set it equal to 0. This is not equal to 0 right now. It's equal to, this equation is equal to -16. So the first thing I need to do is I have to add 16 to both sides. All right, in order for me to use my 0 factor theorem, it has to equal 0. Think about what those words even mean. 0 factor theorem. Set equal to 0, got to be factored. So I'm going to I'm going to add 16 to both sides. So that gives me 9x squared minus 24x plus 16 equals 0. So that's good. I'm feeling good about myself. All right. How does this look on your screen when I have this like double window thing? Is it okay? All right. I know we're used to seeing it full screen, but I want us to see the factoring flow chart. Now, here we go. Factor time. Step 1, factor out a GCF. Is there a GCF for this problem?
be 3.
Are you sure? What number times 3 equals 16? If you don't know, Amanda, honestly, just start writing them out. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4, 12. 3 times 5 is 15.
Oh, no.
Yeah, nah, doesn't work. Although, I do like the way you were thinking. It's just, you saw that 6 and the 16, and you're like, oh, maybe a 3 will work. Unfortunately, it doesn't. I've made that mistake a million times, so don't worry about it. So is there a GCF, yes or no? No GCF, and that's fine. Polynomial type, we got 3 terms. So it's definitely a trinomial. So it's a trinomial. Now, you got 2 pathways. A equals 1 or A does not equal 1. Last time I checked, 9 and 1 are definitely different, correct? So, does not equal 1. Therefore, we need to use the AC method. This is what I think, worst case scenario. This is the worst case scenario because you got to use the AC method, which takes some time. So let's go through this. Let's be careful. All right. There is another way to do this problem, but I want to review the AC method, so I'm forcing us to use it. So step 1, let's get an idea. Remember what I mean by an idea. I just want to know what the signs are. That's it. That's my idea. I know my answer is going to look like 2 binomials being multiplied and they're both negative. Okay? I know that. Because I copied down the first sign. The second sign has to be a negative. Now, step 2. We need to multiply A times C. So that's going to be 9 times 16. What's 9 times 16? 144. Okay, now you need the factors of 144. So I'm going to start writing them out. It's not fun, but it's better than nothing. So we got 1 and 144, 2 and... what is it, 72? I'm going to get out my little calculator here. All right, what about 3? I can't do that.
48.
Yeah, 3 and 48. What about 4?
36.
36. 5 definitely doesn't work. What about 6?
24.
What about 7? I don't think 7 works. Yeah.
It doesn't.
Yeah, what about 8? 8, and I think it's 18.
No.
Okay. 9 and 16. Okay, we got to keep going. 10 doesn't work. 11 doesn't work. Oh. How about 12 and 12? 12 and 12 look good. All right. Now remember, you need 2 numbers to multiply to give you 144 and combine to give you negative 24. And you know from step 1, both of those numbers are negative. There it is right there. Negative 12 minus 12 is negative 24. So what I'm going to do here is this. I'm going to wait a minute so if you want to copy this down, you can. But this entire column of factors, I'm going to erase. I'm going to erase in a second here. Okay, I'm going to take a nice drink of water. All right. Here I go. I'm erasing. And directly underneath, I'm just going to write negative 12 minus 12 equals 24. So step 3, we're going to rewrite that middle term. Negative 24x equals negative 12x minus 12x. And our last step, Now we can finally factor by grouping. So I'm going to rewrite the problem, 9x squared, and I'm going to write my middle term as minus 12x plus 16, and all that's going to be equal to 0. Like I said, this is the worst case scenario for us. Factor by grouping. I group the first two terms. I group the second two terms. And remember, since that middle sign is negative, my second grouping sign changes. So since it was positive 16, it is now negative 16. Now I look for little mini GCFs. So in the first set of parentheses, I could definitely factor out a 3x. That's going to give me 3x minus 4. In the second set of parentheses, I can factor out a 4 to give me 3x minus 4. All this is still equal to 0. Now, I am the happiest person alive because my binomials inside the parentheses match. They are both 3x minus 4. I know I'm right. So I factor out the 3x minus 4, which is inside the parentheses. And then what's ever left over goes inside the second set of parentheses, which is just another 3x minus 4. So, step 2 is now done, which is factor. Does that make sense, everyone? Like I said, this is the worst case scenario, is you got to do the AC method because it takes so much time. All right? Are there any questions? Now, remember, we are solving. So what I'm going to do is just go over here to the right a little bit. I'm going to rewrite the problem. And now I'm going to set each one of these equal to 0. Okay? So 3x minus 4 equals 0 and 3x minus 4 equals 0 again. But here's what's nice. Since they're both the same exact thing, I'm just going to solve one of them. So for the first one, I just add 4 to both sides. Then I divide by the number in front of the variable. And I know x equals 4 over 3, which means in the second binomial, x equals 4 over 3 again. Okay? And if you ever have an answer that repeats, we just say that the answer is x equals 4 over 3 with a multiplicity of 2, meaning it repeats twice. Okay? Multiplicity of 2, meaning it repeats twice, which is actually a very funny movie. It's called Multiplicity. It's with Michael Keaton. It's like a 90s movie. It's pretty funny. So if you're ever bored and you see it, it's free on Netflix or Amazon Prime or something. You can watch it and then you can tell me about it. And then if you tell me your favorite part, maybe I'll be nice and give you extra credit or something. I don't know. Okay? I'm going to wait till you're done. I'm sorry. I'm moving way too fast. I'm that avalanche again. What time is it? 10:21. And my Apple Watch is fully charged. I like getting those notifications. Anybody else have an Apple Watch? They're the most useless piece of technology. Like, nobody needs one. Yet, they figured out a way to get me to buy one. I think it was peer pressure. All right, so here we go. Number 5. I'm going to put a box around it and put a star. And I'm going to say this. I'm going to zoom in real fast. Whoop. All right. If you can get through number 5, you can get through any of these problems. Because number 5 is a doozy. It was the worst case. You had to use the AC method. There's nothing you could do about that. Okay? That was the hardest one. It really was. All these other problems like 6, 7, 8, 9, 10. I mean, I got a bunch of them here. I got way too many. They're all easy. They're all done the same way. All right? So what I want you to do, please, it's going to take you some time, so I'm going to disappear for a little bit. I want you to do 6 and 7. Okay? Follow your steps. Follow your steps. How we doing? Are we stuck? Are we okay? Okay, are we ready? Or do we still need some more time? No one's saying anything. Somebody give me some guidance.
I mean, I'm stuck on the second one.
You're stuck on the second one? Okay, that's fine. Anybody else stuck on the second one? Second one's kind of tough. I'll admit it. All right, so let's go over it then. We'll go over number 6, then we'll do 7. Number 6, step 1, got to set it equal to 0. That's the first thing. Second thing, I see it looks like it's factored, okay? But I need the x squared term. So what I'm going to do first, subtract 6x from both sides. All right, now I got it set equal to 0. Then I'm going to go ahead and distribute the x. All right, there's my x squared term. So I got 3x squared plus 7x minus 6 equals 0. Next, step 2, I need to factor. Looks like I got to do the AC method again. But luckily for us, this is going to go a lot more smoothly now because it's actually, the numbers are very small, okay? So, get an idea. I know my answer is going to look something like this. The plus and a minus. Step 2. AC method. 3 times 6 equals 18. Factors of 18. 1 and 18. 2 and 9, 3 and 6. I think that's it. Yeah, I think that's it. One of them has to be positive, one has to be negative, and I need to get positive 7. Well, that's right here. So I'm going to rewrite 3x squared minus 2x plus 9x minus 6 equals 0. Now let's group. We're grouping. Am I moving too fast? Are we okay? How's it looking so far? I mean, I will know if I'm right on the next step. Because the next step, I have to find my little GCF. So I can factor out an x. And in the second set of parentheses, I can factor out a 3. So I'm feeling good about myself. I know I'm right. Factor out my 3x minus 2. What's left over is x plus 3. So now that I have it written in factored form, I can set each one of these factors equal to 0. Three x minus 2 equals 0. X plus 3 equals 0. So let's solve each one of these independently. Add 2 to both sides. And then divide both sides by 3. Oh, that looks gross. So for my first solution, x equals 2/3. For my second solution, I just subtract 3 from both sides. X equals negative 3. How we looking? Good or bad? Hard problem. The factoring wasn't as bad as the previous, but it was the worst case scenario. AC method. Now, the next problem. This is the one where I think we got a little bogged down, correct? All right, so let's look at it. So negative 3x squared minus 6x plus 72 equals 0. First thing, I look for a GCF. I could definitely factor out something here. I'm going to factor out a negative 3. That's going to give me x squared plus 2x. Now, what is 72 divided by negative 3? Well, I know it's negative. But what's 72 divided by 3?
24.
Okay. Now the question becomes, can this be factored? Okay? And there's only one way to try it. We factor out the GCF. This is a trinomial, and the number in front of the x squared is a positive 1. So I can go directly into this. Put an x, a plus and a minus. Factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. And I think that's it. You know, one of them is positive, one of them is negative, and they have to combine to give you positive 2. Negative 4 plus 6 equals positive 2. So, this factors down into negative 3 times x plus 6 times x minus 4 equals 0. Are there any questions so far? Amanda, did you get this far?
Oh, I got like screwed up with the first number being negative and polynomials, and I tried to factor out a negative 1.
Okay. Well, factor out the negative 1. In fact, if you would have just factored out the negative 1, okay, and then tried to use the AC method, you would still get to this point right here. You would eventually get to this. It would just take you a lot more time, okay?
Okay.
Now, from here, we set each factor equal to 0. Now, we got to be careful, because when you think about what I'm saying, set each factor equal to 0. I'm going to identify the factors for us, okay? Remember, factors are things being multiplied. So we have 3 of them right here. However, negative 3 does not equal 0. In other words, you don't even have to worry about this one. You set the factors with the variable equal to 0. Exactly what the directions say to do, or the steps. So I set each one of these equal to 0. Subtract 6 from both sides. I get x equals negative 6. I add 4 to both sides to give me x equals 4. How we looking? Pretty good? All right. So here's what's going to happen on Thursday when I see